Okay, welcome to number 5 on the 2023 AP Statistics exam. These are my solutions, working out cold. Haven't looked at this before, so we're going to take a look at it and work it with only the resources that are available to students on the exam. Number 5 says, wildlife biologists are interested in the health of tule elk, a species of deer found in California. An important measurement of tule elk health is their weight. The weight of a tule elk is difficult to measure in the wild. However, chest circumference, which is believed to be related to the weight of the tule elk, can easily be measured from a safe distance using a harmless laser. A study was done to investigate whether chest circumference in centimeters could be used to accurately estimate the weight in kilograms of male tule elk. For the study, wildlife biologists captured 30 male tule elk, measured their chest circumference and weight, and then released the elk. The data for the 30 male tule elk are shown in the scatter plot. Describe the relationship between chest circumference and the weight of male tule elk. Okay. So part A. All right. This appears to be, in this scatter plot, oops, not sharing my video. This appears to be the relation, let's just start with it in context, relationship between chest circumference and weight of male tule elk is strong, positive, and linear. Very much appears that as the chest circumference increases, the weight increases, somewhat proportionally, even though we have some variability there. It's not very far. If we put a line on there, it would not look like it was a bad relationship. So we can say it's strong. All right. So here, part B, the following is the equation of the least squares regression line relating chest circumference and weight for male tule elk. The weight of one male tule elk, let's go ahead and write this line. I'm going to go y hat instead of all the words, minus 350.3 plus 3.7455 times x. Okay. The weight of one male tule elk with a chest circumference of 145.9 centimeters. So y actual, chest circumference and weight, is equal to 145.9 centimeters, and the weight is 204.3 kilograms. That's our actual weight. Using the equation of the least squares regression line, calculate the predicted weight for this male tule elk. This time I am going to use, because I'm going to have to put it in context anyway, for this male with 145.9 centimeters is going to equal negative 350.3 plus 374.55 times our weight, our actual weight, 1.59 centimeters. It's important to show your work. It says that at the top of every FRQ section of the exam to show your work, how you get the results. Minus 350.3 plus 374.55. No, that was 3.745. Did I write that down wrong? I did. 3.7455. Let's fix that. Times 145.9. And that looks like 196.1685. It's 845. We'll just go with that. And this is going to be in kilograms. That's the predicted weight in kilograms. Let's look back at our drop and see if that's very far off. 145.9 at our scatter plot. 145.9, and that would take us to somewhere in the neighborhood of 200 kilograms. So that's not too bad. It's not a bad estimate. This is part I, by the way. Show your work. It said show your work. Calculate the residual for this male tool elk. Okay, so our residual for this actual value of 145.9 is the predicted weight minus the actual weight, which is going to be 196.168 minus 204.3 kilograms. And I'm going to do, it's both kilograms, but so the residual I get is negative 8.132 kilograms. So the equation of the least squares regression line relating to circumference weight per minute, give it to us again. Same one, right? Yes, okay. Interpret the slope of the least squares regression line in context. Okay. So the slope of the LSRL, one of the few abbreviations that I allow my students to use on the exam or in the class, but the slope of the LSRL is 3.7455. You can interpret it without stating it, but the rubric might possibly ask you to state it and count off. It'll take you from an E to a P if you don't. So I'm going to not take a chance, and I'm going to restate the slope. It means that for every 1 centimeter in context now, 1 centimeter increase in chest circumference of a male tool elk we expect on average the weight of the elk to increase by 3.7455 kilograms. That's the interpretation of the slope of the least squares regression line. So now we have D, the sambar, another species of deer, is similar in size to the tool elk. Slope of the population regression line relating chest circumference and weight for all male sambars is 4.5 kilograms per centimeter. So B in this case for y hat equals A plus B times X is equal to 4.5 kilograms per centimeter. A wildlife biologist wants to determine whether the slope of the population regression line for male tool elk is different from that for male sambars. So let beta represent the slope of the population regression line for male tool elk. The wildlife biologist has conducted a test of the following hypothesis using the sample of 30 tool elk. Test statistic was calculated to be 3.408. test statistic. Assume all conditions for inference were met. Let's determine the p-value of the test. Okay, so we're using the 30. So we're going to look at t-distribution. For beta equals 4.5. Our test statistic was calculated to be 3.408. So we're looking at 4.5, 3.408. This is going to be 4.5 minus 3.408. Let's do that. 4.5 minus 3.408. It's 1.092. So that plus, that's what that minus equals 1.092. So 1.092 plus 4.5 equals 5.592. So we're looking for the area here. Okay, this is interesting. This is something I rarely ever get to do well with my students because of time constraints. Because n is equal to 30, we can probably use the z-test, the z-distribution. Or we could convert all of those to a standard score, where we take the x value minus the mean and divide by the standard deviation. If we're given a standard deviation, which I don't think we're given. So I'm going to go ahead and use the one sample z-test because n is greater than 30. So we're going to use one sample z-test because n is greater than or equal to 30. And we're going to say that we can do that. Otherwise, we have to convert it. I don't have a standard deviation. I don't think I had a standard deviation for the 30 mil elk. I don't know that I could do it anyway. All right, so let's go ahead and do this. So we can use the one sample Z. I'm going to use let's see, TCDF. Let's look and see the TCDF real quick. Lower upper degrees of freedom. We don't need standard deviation. So if I was to scale this, divide everything by 4.5, that would be my t-distribution. Nope, that's 1. Let's go ahead and use the z. not seeing in here anything else to convert that. T-distribution. Zero. I guess we could shift it. It would be the same if we shifted it. So subtract 4.5. Let's do that. And then we'll use the TCDF. Might compare it to both of them. So if this was 0 and 3.408, will be negative 1.092. We should have known that. And 1.092. So let's go ahead and do the TCDF. Oops. And let's go 0, or negative 1 to the 99th. That's good. Negative 10 to the 99th. And then negative 1.092. And degrees of freedom 29. And paste. And if I multiply that by 2, that would give me p-value of 0.2838. And interpretation of that was what we were asked to do. Determine the p-value test. Okay. So the p-value is 0.2838. I'm going to go ahead and check this on the z-test just in case, because the distribution is the sample size is greater than or equal to 30. So I'm going to do a second sample. In normal CDF, negative 199 to 1 point. Oh, we don't have a standard deviation, though, do we? Nope, we can't do that because we don't have a standard deviation. So this is what we're going to use. 0.2838. That's all we're asked to do on part I. Let's click the significance level of alpha equals 0.05. What conclusion should the wildlife biologist make regarding the slope of the population regression line for male tool elk? Okay, so in this case, your H naught would have been that beta for tool elk is equal to beta for the SAM dam. And so I'm going to say, since p-value 0.2838 is greater than any reasonable value of alpha, such as 0.01, 0.05, or 0.1, we fail to reject H naught, the null hypothesis, and there is insufficient is the word I'm looking for. Statistical evidence to conclude there is a difference in slopes of the LSRL for samdan. How do we say that? Sambar and tool elk. Okay, like I said, I don't usually get a very good coverage of the inference procedures for the slope, so that might be messed up, but that's the best I could do with the resources and what I would expect out of my kids. So hope you'll enjoy.